so this is our last information. It's called expected value of an event. Okay, so to find the expected value, you take the probability of each possible outcome occurring and multiply it by the number of that outcome, and then add all the products together. So if you have the probability of this event and the value of this event, plus the second probability times the value of that event, plus the third probability times the value of that event, etc., that will give you the sum of all the values, which is the expected value. Now you have this formula on your formula sheet. It's got this big sigma, which means to sum, to add, and then it has an I equals 1 to n. Okay, so when you have this EX, this is called the expected value of an event, of the probability. So you take the value of the event, that's the X is the value, and you multiply that to the probability of that value occurring. And then this big sigma says to add all that together. So that's what this is doing, going from 1 all the way to however many you end up with. And you multiply the probability to the value and then add them together. And that will give you your expected value. So let's look at an example. Okay, so another name for expected values is weighted average. Now you guys do this all the time when you calculate your grade in your class. Okay, so when we have these percentages that we give you for each category in your grade, this is how you get an expected value or a weighted average. So for us, our tests are worth 40%, classwork is worth 35%, our interim is 5%, performance exams are 5%, and the final exam is 15%. So looking at this example with Johnny's student, he has the following grades, so we want to know what can he expect to get in the class. He has a 98 for his classwork, 75 on his tests, his interim was 80, his performance exam was an 85, and his final exam he got an 88 in the class. So what we're going to do is we're going to take these percentages and we're going to multiply them to the values of each category. So our first percentage is the test, so that's the probability. It's 40% probability for his test category, and the tests are 75 grade. So we multiply that by the value or the grade in the class. Okay, the next probability or percentage-wise is 35%, so that's 0.35 for his classwork grade. So he has a 98 in his classwork, so we're going to multiply that by 98 for his grade. And then for the interim is 5%. Now remember, 2 decimals for percentage, so it's 1, 2. That means you've got this blank spot in front of the 5, so that's a 0. 0.05. Multiply that by his 80 for his grade on the interim, plus a performance exam, which is also 5%, so that's another 0.05, and he has an 85 on his performance exam. And then last but not least, his final exam is 15%, so 0.15, and he got an 88 on his final exam. Okay, so if we take our calculator and you just type in all of that multiplications, so 0.4 times 75 plus 0.35 times 98 plus 0.05 times 80 plus 0.05 times 85 plus 0.15 times 88. So if we type all that in, always double check and make sure you got all the numbers correct, and he gets a score of 85.75. So that's what he can expect to get in the class. And since we do not have decimal values for our averages, we would round this up to an 86. So that's what he could expect to get in his class with these grades. Now, we can also do some fun things like games with expected value. So let's say you're playing a dice game with your friend. He's going to pay you $1 for each 3 or 5 that you roll on the die, and he's going to pay you $5 for each 6 that you roll. So you will not get any money if you roll on the other numbers. Would you play this game with your friend? So would you expect to win any money, and how much? So basically you're rolling the dice. So there's a 5, we would have won a dollar. You can roll it again, got a 4, so we wouldn't have won anything. A 6, hey, we would have gotten $5. So far we would have won $6. But that's actually doing an experiment. So theoretically, the expected value of this game would be done by taking the value. So what's the value of getting a 1 on the dice? Okay, well, that is 1 out of 6. Okay, so each value on a dice is 1 out of 6 because it is an equal dice, fair, and that means that all numbers show up the equally likely amount of time. Now, what we want to do with this is to put together our expected values. So our events is getting a 1, a 2, or a 4. That's one thing that can happen because those are the numbers that don't pay off. So our probability for that is 1, 2, and 4. So that's 3 out of 6. So that's a 0.5 or a 3 1/2. And we get no money. So that is our value. That's what we're going to multiply it by, the value. So we get no money for this value. Okay, we also could get a 3 or a 5. Now, the chance of getting a 3 or a 5, that's 2 out of 6 or 1/3. Now we're using fractions here instead of decimals because 1/3 is a rounded decimal. So we want to be as precise as possible, so we're going to stick with the 1/3. And we would win $1 for each of those. So the value would be $1. Now the last one is a 6. So 1/6 chance of getting a 6, but we could win $5 for that one. So if we get a 6, we win $5. If we get a 5 or a 3, we win $1. And if we get the other 3 numbers, we win nothing. So we're going to multiply these numbers together and then add up those products. So you can always make yourself some kind of table like this to organize your information. So 1/2 times 0 plus 1/3 probability times 1 plus 1/6 probability times 5. Now, we don't need the actual answer to be exact, so you can put that in a decimal form. So multiplying by 0 doesn't really do anything, so let's just take the 1/3, 1 divided by 3 times 1, plus the 1 divided by 6 times 5, and you end up with a 1.17. So you could win $1.17 for this game. So that would be a good idea to play this game with him. So, because you could win money, more than likely going to win money. And you don't have to pay anything, so you're more than likely going to win $1 at least. Okay, so that sounds like a good thing to do. Okay, so let's look at the next slide about expected value. Another game, Jake has a bag of marbles. There are a total of 30 marbles in the bag, 8 red, 12 blue, and 10 green. The marbles are worth 5, the red marbles are worth 5 points. So right here it says the red marbles are worth 5 points. So there are 8 red in the bag, and they're worth 5 points. The blue marbles are worth 3 points, and there are 12 blue marbles in the bag. they're worth 3 points. And then you have green marbles that are worth only 2 points apiece, and there are 10 of them in the bag. Now we have a total of 30 marbles. Okay, so that's our possible outcomes, 30 possible outcomes. Okay, now we're just drawing once. So we're looking at drawing one time each of these different possibilities. Okay, so the possibility are events. We have the event of getting red. We have the event of getting blue. And we have the event of getting green. Those are the three things that we have a possibility of doing. Now, the probability of each of these events, well, there are, what did it say, 8 red? 8 red in the bag, so that's 8 out of 30. There are 12 blue, so that's 12 out of 30. And there are 10 green, so that's 10 out of 30. And we don't have to reduce these at all because we're not looking at those values as our answers. We're just using those in our calculations. Okay, now the value of each of the marbles. So for red, it says they're worth 5 points. The blue is worth 3 points, and the green is worth 2 points. So if we take our multiplications again, 8 out of 30 multiplied by 5, the value, plus 12 out of 30 multiplied by 3, plus 10 out of 30 multiplied by 2. So this would give us our expected value of the point value that we could win in this game. So quickly over here, taking our calculator, 8 out of 30 times 5 plus 12 divided by 30 times 3 plus 10 out of 30 times 2. That gives me a 3.2. Okay, so 3.2 would be the expected value of this game. Now, could we get higher? Yes, because we could get a 5. And could we get lower? Yes, because if you draw a green one, you're going to get a 2. So if you're only drawing once, then you could expect to get a higher or a lower value. But the expected value for this, because of the number of marbles, is going to be a 3.2. Okay, so using the same marble game from the previous page, if you had to pay $1 to play the game and you could win $10 if you scored 3 points or more, would the game be worth playing? Well, considering our expected value from the previous game, from the previous page, was a 3.2, that would mean that we're expected to get over 3 at any time we draw from the back. So if we paid $1, but we can get a $10 payout, which would be a net score of $9, because we have to think about the fact that we had to pay $1, so we're still losing that dollar that we paid, but we earn $9 payout. Okay, yes, this would be worth it because it's expected that we would get that $9 payout because our expected value is greater than 3. Okay, so if we had gotten expected value lower than 3, then this would not be a good way to play it, because then we would more than likely lose our dollar and have a loss for the game. So carnival games and stuff, this is kind of what you have to look at when you're doing this is the expected payout on those things. And most of those are geared towards the carnival, so your expected payout would be probably a negative value, which is possible to do if you're talking about games of chance. It is possible to get a negative expected value. And in that case, especially when you're dealing with money, you do not want to play something that's going to make you lose every time. All right, I believe that is it for today. Yes. So last thing was expected value. So the summary basically just make sure you figure out the probability, the value of each event, and then multiply those together and add those products. That would be your expected value.